All right, I already told them, so Devin, if you're watching this video, I already told them on 9-7, we're talking about inverse trig functions, okay, that I will give you the graph of these inverse trig functions just so you can kind of see how this works, but I won't make you graph these. Like, none of these should be graphing, I don't think. Kaylin, have you already started looking at your homework assignment? I don't think any of them.
She has.
Oh, it's not up there.
Use a graphing utility. So.
Okay, well, maybe. We'll see. So, you should not have to graph any of these functions. I'll check out the homework assignment first, okay? But you should not have to graph any of these functions, all right? So an inverse trig function, if I'm looking at like sine, well, let's make a little table here. Sine, cosine, tangent, okay? Sine, cosine, and tangent, or the originals. Those guys are the original trig functions, the original main ones, okay? Then sine goes with cosecant, right? Cosine goes with secant, tangent goes with cotangent. But those are not inverses, right? What are those guys called? Cosecant, secant, cotangent.
What's that word?
Yes, they are reciprocal, right? Reciprocal. Those are reciprocal trig functions because like cosecant equals 1 over sine, etc., right? That means the reciprocal, you're flipping it, right? That's reciprocal trig functions, okay? Now I'm doing this to show you that reciprocal does not mean the same as inverse. If I'm taking the inverse is sine, it looks like to the -1 power. That's the inverse, okay? You have on your calculator an inverse sine button, right? It's like shift and then sine. This is a dumb calculator, but I'll show you on this dumb calculator. So here's the sine button. The inverse sine button is like second that button, right? You have an inverse sine button. Now you do not have a cosecant button because they're different from each other, right? So secant is cosine. The inverse of cosine would be cosine to the -1 power, it looks like, and this would be inverse tangent. Okay. Now there are times when you use inverse sine, inverse cosine, inverse tangent. Okay, and they usually involve when you're solving for an angle. So we'll talk about that later. But there is a difference between reciprocal and there's a difference between inverse. Yes? Okay? Awesome. All right, so let's go down here. Now, arc sine is the same thing as inverse sine. So sometimes they will call it arc sine and sometimes they will call it inverse sine. Those two things mean the same thing. Yeah, it's written right here. Those two things are interchangeable, so if they call it arc sine, don't get confused. Those mean the same thing. Same thing with arc cosine. And arc tangent, those just mean inverse cosine, inverse tangent, okay? So here is what sine looks like, okay? The sine graph is this little bubble, goes up and down and blah, blah, blah. This is what sine looks like, okay? Now, inverse sine is taking that guy and rotating him, basically. We're kind of flipping him, but we're like interchanging the x and y axis. So where this before was x, now it's going to be the y-axis. This is going to be the x-axis. So basically what's happening is arc sine does this guy, right? He does one of these. And he keeps going like this, right? All the way down. Yeah? Okay? Now, the problem is, if you do arc sine and you do him all the way down, and like you make the swivels go all the way down, and you try to do the vertical line test on that thing, it does not work. Right? Because he's going to touch an infinite number of points. So it is not considered a function, unless FCN, I'll just do FCN. Not a function. It's not considered a function unless we restrict that guy. So they restrict the inverse sine of the arc sine so that we're only looking at this section right here of it. Does that make sense? We're only looking at that section because if we cut off the rest of it, if we just chop him down to that, I can do the vertical line test on him and he passes, right? He is no longer not a function. He's a function now, okay? So again, we'll not get into that stuff really a whole lot, not the graphing, but I'll show you like why. Basically what it boils down to is this. If you use your calculator to find an inverse sine function or you do inverse sine, really, if we did not restrict the domain, there should be an infinite number of answers to your problem, right? It could be like this as an answer, or this as an answer, or this as an answer, or all the way down, right? But your calculator will only give you one answer back. It's the answer that is in this range. Does that make sense? That's why it's restricted. What? Why can't you do inverse sine of 50? That's a good question. Why can't you do inverse sine of 50?
Because
I'm an idiot.
Because, why? So Kay just asked this question. Why can't you do inverse sine of 50? There should be an X right there. Why can't you do inverse sine of 50? This is like saying what X coordinate will give me a Y coordinate of 50. Okay? If sine looks like this, what does sine go from? -1 to 1. So, Cade, where does sine touch all the way up at 50 at? It doesn't, right? It only goes between -1 and 1, and that's it, right? Now, if you change the amplitude to 50, if you do this, then he will touch, right? But he only bounces between -1 and 1.
stop doing
What? Anyway, so that's why you get an error, right, Cade? Right, Cade? Because they'll never go all the way up to 50, so we're good. All right, so the graph of that is not really terribly important other than the fact that inverse sine is restricted just to the first answer, right? We could have an infinite number of answers if we keep going up and down. But inverse sine is only going to be that first answer, all right? So, definition, blah, blah, blah. Let's look at this one. Find the exact value if possible. Arc sine of -1/2. So let's talk about what this means. This guy says, if you like to write it like this, inverse sine of -1/2. I'm trying to figure out what that is, okay? So if inverse sine of -1/2 equals x, what this is saying is that sine of some x equals -1/2. Does that make sense if I flip it around like that? Okay? Inverse sine of -1/2 equals x can be flipped around to sine of x equals -1/2, and then I'm just solving for x. So this just means, what am I taking sine of so that it's -1/2? Where can I take sine and have it be -1/2? Does that make sense? Yes? Yes. Okay, now, here's the issue. Here's where the inverse, domain comes into play, all right? Let's look at your unit circle. Which one is sine, x or y? Sine is y, right? Okay, so where is sine -1/2? There should be two places on your unit circle. Where is -1/2? That's 7 pi over 6. And -1/2 is here at 11 pi over 6. Now, only one of those answers will show up on my calculator. It will only be 11 pi over 6, okay? So let me have you write something in your unit circle. If you have your unit circle out right now, write this in real quick. I'm going to do it in a really dark color because I already have a bunch of junk on this thing. I don't know. Well, it shows up dark on pink though. Inverse sine is either here or here, right? You guys remember writing that on your unit circle last year? Okay? Inverse sine is either in the first quadrant or the fourth quadrant, okay? So if he shows up in any of the other two, that's not what's going to be in the domain of inverse sine. So basically, 7 pi over 6 is not going to be considered an answer. It's only going to be 11 pi over 6, right? So the answer to this guy is x equals 11 pi over 6. 11 pi over 6, and not 7 pi over 6, because he's not in the domain of sine, right? Sine only is the first and fourth quadrant, okay? Now let's talk about cosine. Where does he live? Cosine lives in the first quadrant, yes, but where else? Second. First and second is where cosine lives. So if you have an answer and we're talking about cosine and he's in the third and fourth quadrant, you won't consider that to be an answer because that's not in the domain. Because we have to chop it up, otherwise it's not a function anymore, right? Okay? Let's talk about tangent. Last one, tangent. Where does tangent live? In the first quadrant and?
Third.
It's not the third.
Fourth.
It's the first and fourth. It's the first and fourth. So tangent lives here as well because tangent is very similar to sine. It has to do with the fact that cosine is an even function and sine and tangent are both odd functions, okay? So sine and tangent are very similar to each other, right? Okay? So there's that, all right? So anytime you have an answer that's in two different quadrants, this will tell you which one you use. So since 7 pi over 6 was not in the domain of sine, so 11 pi over 6 is not our answer, okay? So let's do the same thing here. If it helps you to write this, sine of x equals the square root of 3 over 2. That's what this means, right? It means I'm taking sine of something and getting the square root of 3 over 2, right? Sine of something is the square root of 3 over 2. So let's write our answers. Square root of 3 over 2 shows up as where? Pi over 3 and where else? I'm going to do both of them even though you guys know the trick. and 2 pi over 3. So my answers are either pi over 3 or 2 pi over 3. But which one is not in the domain of sine? 2 pi over 3 gets nixed out, so pi over 3 is my only answer. If you do inverse sine of square root of 3 over 2 and put your calculator in gradients, it will only give you back pi over 3 as an answer, right? And not 2 pi over 3. It'll probably give it to you as a decimal, though, if you try to do it, okay? All right, so that's why, because it's not in the domain of sine. Otherwise, we would have an infinite number of answers, right? Okay, last one, sine, inverse sine of 2. This means sine of x equals 2, okay? Now, I don't have a 2 on my unit circle, but let's just think about this. Where does sine of x equals 2?
It doesn't happen.
It doesn't happen for the same reason sine of x never touches 50, right? Sine only bounces between 1 and negative 1, right? So what's the answer? No solutions. It will not touch 2 ever, right? Unless we change the amplitude or something like that. But normal sine of x will not touch 2 ever. Does that make sense? So that can happen. All right, let's go down and do a little bit more. Other inverse trig functions. So this is talking about cosine. Inverse cosine, okay? Inverse cosine, inverse tangent is just saying what quadrants those are in. So from 0 to pi, that's talking about the first quadrant and the second quadrant. And we've already labeled that on a unit circle. First quadrant, second quadrant is where cosine lives, or inverse cosine lives. From negative pi over 2 to positive pi over 2, that's where inverse tangent lives, right? So this is the first quadrant and the fourth quadrant. That's where inverse tangent lives. We already have those labeled on our unit circle. That's what we just did. So they're telling us this now. All right, let's go to the back side. Let's see what we can come up with here. So this is the graph of arc sine. This is the graph of arc cosine. This is the graph of arc tangent. Again, they've cut those off at these places because otherwise he would start to repeat again, right? And we can't have him repeating because he doesn't pass the vertical line test because he's not a function then, right? Does that make sense? Okay. Tangent's the same way. Okay. If we would do another cycle of him, he would start to repeat again. So find the exact values. Arc cosine of square root of 2 over 2. This means we are looking for an x such that the cosine is square root of 2 over 2. I'm looking for an x such that the cosine of it is square root of 2 over 2. So look at your unit circle, because I have those. Square root of 2 over 2. For cosine, cosine is the x coordinate, so I have one at pi over 4 and at 7 pi over 4. Right? That's square root of 2 over 2. Pi over 4, 7 pi over 4. What?
Slow down.
Okay. What?
Watch your tone, young lady.
Slow down, please. Do you need me to
Go back to the notes.
go back to the notes?
Yeah.
Okay. Okay. Sorry. You're welcome. We'll pause for just a second. I'll drink my coffee.
Hey, how about you get off your phone?
Okay.
Let's see. Assignment. You want? I'll write it on board.
I don't want this
Well, we're waiting for Finn. Okay, please stop me. I appreciate that you do that.
Why?
9 and 7.
So, I still don't know what the... Yeah. I still got 2 assignments to do.
Are you serious? Page 626, 8 through 72 by 4. That sounds like a lot. Holy cow. And 1 to... Oh, yes. Everybody laugh at poor Maddie. Or cry with her.
That was hilarious.
So this is what Maddie did. You ready for this? 12 through 28 by 4. That's a 2, right? She did 12 through 88 by 4. Yikes. Make sure I have the right problem. And then she didn't understand. She's like, wait a second. How does this work? Because 60 is a multiple of 4, so why did you write it again?
Big brain.
She did way too many problems. Way too many problems. Okay? All right. Are we ready, Trin? Are you okay? Okay. So we are looking for a cosine or an x coordinate such that the cosine is the square root of 2 over 2. So square root of 2 over 2 as the cosine is right here and right here. So pi over 4 or 7 pi over 4 are what I'm looking at. Pi over 4 or 7 pi over 4. And that is Which one is in the domain of cosine? Just pi over 4, and that's it. 7 pi over 4 is not there. So my answer will just be pi over 4. Okay? Arc cosine of -1. That means that I'm looking for a cosine of x such that it gives back to me the value of -1. Okay? So cosine is the x coordinate. Where is the x coordinate -1? At just pi. Is pi in the domain of cosine? Yes. That one we don't have to choose because there's only one value where cosine is -1. Yeah? Only one value. Next, arctangent of 0. So I want to know where tangent equals 0. There's two places where no, there's only one place where tangent's 0. No, there's two places. There's two places. What? Oh, shoot. 0, pi, and 2 pi, right? But which one do we put? Ouch. Ouch. 0 pi, 2 pi. Where does he live? Let's think about this.
Why do you put 0, 2 pi, and 2 pi?
Because 0 and 2 pi are the same thing, so we have to determine which one we put. Okay, which one do we put? According to tangent, he is living between -pi over 2 and +pi over 2. So 0 is the answer. 0 is the answer because 2 pi does not live in that range. Does that make sense? -pi over 2 to +pi over 2. 2 pi is not in that range. So even though 0 and 2 pi mean the same thing, we only put 0. Make sense? Kind of. That was kind of a weird one. Okay, use a calculator to solve arctangent or do inverse tangent of -8.45. Do we want to be in radians or degrees? It doesn't matter. It doesn't matter. Your x will come back as radians if it's in radians and as degrees if it's in degrees. So let's have somebody do radians, somebody do degrees, and we'll figure out which one is, or figure out the answer.
-83 degrees.
What? -83 degrees? -83.25 degrees?
Yeah,
0.25 degrees. Okay, what is that in radians? If you have your calculator in radians, do the same thing. No, because I don't know what your book wants. It will say either radians or degrees. I think. It doesn't? It doesn't? Okay, then you can choose which one. But let's do both for right now. What? -1.45 radians.
How do you go from degrees to radians?
What?
Is there like a way to get from...
Yes, pi over 180 or 180 over pi. Yeah. Do you know how much one radian is? How many degrees one radian is approximately? 56 degrees-ish. Right? That's just kind of a stupid fact. Okay? Arc sine, so inverse sine. Inverse sine of 0.2447. Do that. X is equal to, give me radians and degrees. You can pick on your homework assignment which one you want to do. Radians is 0.247, and degrees is like maybe 10, maybe 8. 14.16 degrees. Yep. I'm just looking at 0.24 times 56, 14.16. Right? That would be about, yeah, something like that. Okay, good? We got an 08. Okay, couple left. Here we go, couple left. Compositions of functions. Compositions of functions. Are we ready for this? La la la. Sometimes they cross out. Sometimes they cross out, okay? So, when it says tangent and arctangent, those two go away, and it's -5 is the answer, and we love life because it's really nice and easy. But then you go to the other one. Ugh. Ugh. Arc cosine is 2/3. Let's focus on just this. So the part that's in parentheses says that cosine of some x value is 2/3. And I don't have a 2/3 on my unit circle, right? I don't have a 2/3. So let's draw what he looks like. Let's make a triangle. so that cosine is 2 over 3. And if he's positive, I always just put him in the first quadrant. So this is what my triangle looks like in the first quadrant, right? That's my right triangle in the first quadrant. This is my x, my angle x. Okay? So cosine of that x is 2 over 3. So where does 2 go and where does 3 go? Cosine is what? Adjacent over hypotenuse. So the adjacent side is 2. The hypotenuse side is 3. How do I figure out what this guy is? 2 squared plus question mark squared equals 3 squared, right? It's the square root of 5. 4 plus question mark squared equals 9. Question mark squared equals 5. Right? Are you following me? Are you doing okay? If I take the square root, this guy is the square root of 5. Okay, now that can help me. Now that I know what he looks like, this part that's in parentheses, this whole part right here, helps me identify what he looks like. But I want tangent of that thing. I want tangent of that thing. So what is tangent of that thing? Tangent is opposite over adjacent, which is opposite. I'm going to write tangent of x equals opposite is square root of 5. Adjacent is 2. That's what he looks like. Does that make sense? Yes? Yes? Now, can we just cross 3 out?
Yes.
No. Cosine and arc sine do not cross out. Cosine, arc sine don't cross out. Do I have a negative 3/5 on my unit circle that I can look up? No. So I have to draw it. And arc sine is negative 3/5. So it's negative.
How do we know which
Which quadrant am I going to draw this guy in? Actually, you know what? We can just draw it in the first quadrant. It's just going to look kind of funny. Yeah, we can just draw it in the first quadrant. It just looks stupid saying, well, no, that's not going to work. That's not going to work. We're going to have to draw it in whichever quadrant. So, arc sine. Which 2 quadrants involve arc sine? First and fourth. It's not in the first quadrant because first quadrant sine is positive. So it's got to be a triangle in the fourth quadrant. Does that make sense? Does that make sense? Yes? Wait. Do you see why we say that? What? You don't see why we say that? So we're looking at arc sine. We're just looking at this inside part here, right? This says that sine of some x is negative 3 over 5. That's what this thing says. Okay? Now, arc sine is only in the first and the fourth quadrant, up here or down here. So I could draw my triangle like this, but it's negative, right? So we have to choose it as being in the fourth quadrant, right? Okay. Now, that helps me determine which one is negative, the 3 or the 5, okay? So cosine, or excuse me, sine is opposite hypotenuse. So opposite is 3, hypotenuse is 5. Oh, baby, this is going to be nice. Which one's negative? 3. Okay, what's this side right here? 4. That's a 3, 4, 5 right triangle. Okay? Now, I'm not interested in sine, though. This just tells me what he looks like. What is cosine of that guy? What's cosine of that thing? 4 over 5, adjacent over hypotenuse. 4 over 5. There you go. Okay? Woo! All done.
Can I just turn this in and maybe work on Monday?
Let me turn the video off.